Hello and welcome to my video on deriving de Moivre's formula. Before we begin, I'm assuming that you're familiar with writing a complex number in its polar form. To begin, we can define two complex numbers z and w in their polar form. The argument of z is theta and that of w is phi. In order to derive the formula, we must first find out what happens to the arguments when the two complex numbers are multiplied. Pause the video and try it yourself. To multiply, we expand the parentheses and multiply the modulus. Now, pause the video and try to rearrange the terms in the parentheses and simplify. You should have realized that by rearranging the terms, it is possible to rewrite the expression using the trigonometric identities for cos x plus y and sin x plus y. So we've shown that the argument of the complex number zw is the sum of the arguments of z and the argument of w. So we can say that the argument of zw is equal to the argument of z plus the argument of w. In other words, when you multiply two complex numbers, you add their arguments on the argand plane. Now, using this information, pause the video and try to derive an expression for the argument of z to the power n in terms of the argument of z. You should have realized that this is the same thing as adding the argument of z n times. A similar process can be used to find the modulus of a complex number z to the power n. Using the information we know, it is now easy to derive de Moivre's formula by writing a complex number z to the power n in polar form and simplifying. Try it out yourself. If your expression matches the one in the box, congratulations, you've done it. Since the argument is added n times and the modulus is multiplied by itself n times, we can write z to the power n in this way using polar form. If you have any questions, please add them in the comments section below. Using Euler's form, it is possible to do this derivation in 2 steps. Try it. Thank you for watching and see you next time.